Hello guys, my name is Rupesh Vasu and I have been taking classes for digital electronics for quite a while now. Now we have already gone through the combination circuits and the basic part of the sequential circuit. As you know, the sequential circuit is nothing just the part when you are adding a memory element and the feedback circuit in a combination circuit, then it is a sequential circuit. Now, this sequential circuit has been used to actually adding information into a digital world. Now, whenever you need to have these memory devices, and these memory devices will act as if uh, they will store information, but somehow you are not going to see that information. And these are just the basic elements, the first part of these memory devices. So we will be talking about these things. Now, the first thing which comes into our mind as in the devices which have been used for this purpose are the latches and flip-flops. The latches and flip-flops are the basic elements of any kind of memory devices. As you know, in any kind of logic gates or whatever you're using, they are not actually saving information or actually putting the information over there. There is no terms of storage out there. You just process it. But when you use the multiple logic gates, then you can design a particular element which can be used for memory purposes, which can be used for storage purposes. Now, this is the basic example of that, the latches and flip-flops. Now, as you can see, there are two inputs available to us, and there are two outputs available to us. Now, two inputs and two outputs. The first output is basically the normal output, and the second output is basically the inverted output, Q and Q bar. So, whatever output you are providing over there, the reverse or inverted output will be provided over there. Now, first we need to understand basic terminologies of these memory elements, these sequential circuits. So I have put it over there. Whenever you are talking about a flip-flop, basically flip-flop is nothing but a bistable multi-vibrator circuit. A bistable multi-vibrator circuit means there will be two stable outputs which can be stored over there till the time there is an external trigger will take place. Now, external trigger, whenever this trigger pulse will actually takes place, then what happens is this information will be changed. Like 1 becomes 0, 0 becomes 1, or whatever other stable outputs is available to us. So Q becomes Q bar and Q bar becomes Q. So this is how this will work out. So whenever in examination they asked about the bistable multi-vibrator, basically the bistable multi-vibrator and flip-flops are the same mechanism, same kind of mechanism, so they can be written in that manner too. The second thing, it is a memory device which stores data. Yes, I have already told you about this thing, that this is actually used to store some kind of a data. Now, what kind of a data we are talking about? Now, it is basically 1-bit memory element. Now, there is only one stage which can be used for this purpose till the time the trigger pulse will take place. Now, if you are talking about this one, that there is a possibility of change in stage or a change in state of that particular circuit. So, that particular bit will be stored till the time there is no trigger pulse, and you can check it out whether what is that pulse. So as per your inputs you can actually vary them. Now the second term in this is the latches and flip-flops. Why latches? Latches is basically, if in the general terminology you use that particular term, the latches are the locks. The locks which can be used to lock some information. So 1-bit information can be locked. So that term is latch. And there is a flip-flop. So what is the difference between them? So I illustrated basic three difference between flip-flops and latches. Now the first one is the output will change by level triggering here in latches. Level due to level change of levels, the output will be changed in that particular memory devices. But in flip-flop, it is the age triggering which takes place. I have already gone through this one, which is the level and what is the age. Now this is the age part where it is changing. When the age is happening, age of what? Now here the age of the clock pulse, and or if you are using the clock pulse, the age of the triggering pulse will actually change the output in flip-flop. The second thing, the inputs which has been used in this are asynchronous. These are asynchronous inputs, whereas in flip-flops, the synchronous inputs has been used to actually get the information. And the third one is the output changes as per input till enable is high. Here enable, this extra enable pulse has been used for this purpose, and this enable needs to be high. If enable is not high, this will not be there will not be any output change in latches. But in flip-flops, the output changes at triggering point, and that is age triggered. So these are the 3 points, basic 3 differences between latches and flip-flops, which we need to understand. Now latches and flip-flops are quite different, yes, but they have been used quite frequently and like synonyms, but no, they are different. Yes, there are some similarities. Yes, output has been changing, but it is not as if both are the memory elements, but there is some difference like synchronous, asynchronous, level triggering, age triggering. So these things needs to be considered before talking about this thing. Now we will move towards the next part of this. The next part of this problem and latches and flip-flop. The first thing which comes into our mind is how you are going to make them. So is there any particular circuit by which we can make them? Yes. The NAND gates and NOR gates are the basic elements by which any information or any circuit can be made. I hope you have noted down this one. Now we will talk about the next thing. What is the next thing? Yes, the NAND gate. I beg your pardon. I have been facing this problem for quite some time now, so I hope you will understand this. Now, to make any device, there are 2 inputs. Now, these inputs will be shown like this. Now, this output is Q and this output is Q bar. Now, as we understand that any sequential circuit, the feedback will be provided. So feedback will be provided, that means here it is like this. In the same manner, it is like this. To differentiate between them, use this. Okay. Now A1 and A2s are inputs and Q and Q bar are the outputs. For to design a basic memory element, we use this circuit. Now these are just the NAND gates. Okay. Now to illustrate this, so Q equals to A1 bar equals to A2 and Q bar becomes A2 bar becomes A1. Basically, you can use this circuit like this or like this. Instead of doing this, you can actually show it like this, so that you will understand this equation 2. So what is saying is the first output, the Q, the normal output is basically A1 bar, right? And that is A2 because this output is going towards this one. The same manner, Q bar is basically A2 bar and that is A1. So both are. So what is it showing is, now we can understand there are two states. The first stage is set state. Now this element will be called in set state when Q is high. Whenever we are using high, that means logic 1, and Q bar is 0, is low, logic low, that is logic 0. So these two terms are there in set. Again, if we are saying in reset state, in reset, Q is 0 and Q bar is logic 1. So this will be called a reset. So there are two states, the set and reset state, to actually illustrate the formula. Now for flip-flop to act as a memory element, it should retain the information. Now we will talk about two things which we have already understood, but we will talk about it because it is essential for you to learn. The first thing is age triggering and the second thing is the level triggering. Now we will talk about triggering. Now it is of two types. It is not working as if I would have wanted. So these are two types. Triggering is age and level. As we have understood, the level triggering and age triggering are two types. Now it can be positive, it can be negative. The same manner, it can be positive and it can be negative. So there will be two terms, positive and negative, positive, negative, age triggering and level triggering. Now how to show this? If you are talking about the now this is called when you start with the lower level and go towards the positive side or active high side. So this is called positive age triggering. Now if you want to show the negative age triggering, what you're going to do is you will start from level high. Now this age will define it. This one is the positive age triggering, this one is the negative age triggering. Now you can see over there, from this moment it is at logical high. From this part over this here, over this age, it is actually going towards a lower side or active low. So this is called negative age triggering. And here what is happening is it starts with negative and going towards positive. So from this level to this level, or from this age, it will be positive age triggering. Now we will talk about the level triggering. In the level triggering, Again, it start with active low and ends on in negative. Start with negative. Now here we will consider this. Here we will consider lower level to upper level. Whenever it is going from logic 0 to logic 1, here it is logic 1. This is called positive edge, positive level triggering, and here we are talking about this one throughout this level. During this level, it is negative side. Here it is +1. It is 0, logical 0. It is moving towards the 0, so it is called negative level triggering. So both the terms are used. Now, as you have understood which one is used in flip-flops and which one is used in latches, you have already gone through it. So you just need to understand how triggering works and edge triggering works. Here in the triggering, like in the positive edge triggering, here edges are counted over there, this point. Here this level is counted, this level to this level. So two levels are there, upper level, lower level. Here the level has been defined, and here we only talk about the trigger, edge trigger. So at the point of edge where it is down falling from positive 0 to 0, logic 1 to logic 0, then it is called logic 1 to 0. Here you can see this. It is called negative edge triggering. Whenever it is going from logic 0 to logic 1, it is called positive edge triggering. Just these are the differences between them. An examination, if they ask about this one, where it has been used, you can give the examples of latches and flip-flops. By this, you can actually make the difference between the two sides and two triggerings which has been used in this. Now the first one is the SR latch. Now SR latch is the one of the basic example, or here it is called set reset. Set reset. Now in the set resets to one, this SR latch, what is happening is, it is the simplest kind of form. Now we need to just clean it out so that we can show SR latch. Basic circuit remains the same. So whenever we are saying SR latch, what is happening? What kind of triggering will be used? You have quite understood that. Now this is SR latch. Now it will be two cross coupled NAND gates, or we just need to conduct like this. So this is set, this is reset. Here is a NAND gate, here is another NAND gate. This output is Q, this output is Q bar. Now here this output will be goes like this, and this output will be goes like this. Now to write it down, SR. So output will be 0 0 0 1 1 0 1 1, and the Qn plus 1 output is, and the state will be defined by this. Now there are four logics available to us. The first logic is 0 0. Here as set it's at 0 and reset input as at 0. So both the inputs are 0. So output is X and it is called forbidden. Forbidden, so that we don't need to understand it. Just let it go. It shouldn't be there. Now the second one is set is 0, reset is 1. As we have understood, whenever it is a set condition, in set condition, set should be high and reset should be low. But in this condition, set is on 0 and reset is on the one side. Now this output is 1 and this is called set. Now set becomes 1, reset becomes 0. Now set becomes 1, reset becomes 0, the output becomes 0 and this condition is called reset. The last condition, when both the outputs are logic high. So both the outputs are logic high, then this condition Qn plus 1 or next stage will be same around Qn. So Qn and Qn plus 1 will be same and this one is called halt. That means it is storing that particular output here. So Qn and Qn plus 1 will remain the same. Whatever the Qn output was, the Qn plus 1 will remain the same. So next logical state will remain the same. Here let me remind you again, it is not Q and Q bar. It is Qn and Qn plus 1. So you just need to distinguish between both terminologies. Now S is there, R is there, Q is there, Q bar is there. Now we will talk about it. Again, we are going to use, here it is used by NAND logic. This is NAND logic. What if we use NOR logic? Output will be changed? Yes. By changing this scenario, the output will be changed. How it is going to be changed? Let me show you. If you are using a NAND gate, it is that output. In the NOR gate, the output will be changed. And how it will be changed? Here it is R, here it is S. Now the condition will be, it will be like this. The condition will be S, R, Qn plus 1 and state. Both are 0. It is Qn 0, 1. It is 0. This condition is called reset. This condition is called halt. 1, 0, it becomes 1 and this output becomes set. And the 1, 1 output is X and that is forbidden. Now you can see the difference between them. If you are using a NAND gate, during 0, 0 condition, the output is X and that is forbidden. But in NOR gate, when the output is 1, 1, then it is X and that is forbidden condition. Again, when S and R are 0, 1, here, the condition is called set. But in here, 0 and 1 becomes 0 and this condition is called reset. Because output is 0, the next output has become 0. Again, in 1, 0, it is 1. Here at 1, 0, it becomes 0. And the halt condition are reversed too. Whole condition, whole scenario has been reversed. This is the end of your SR flip-flop. If you have any queries, please write down in the comment section. Please like, share and comment, because I have been making these videos with lots of research and lots of painstaking examples, and I hope you will actually feel benefited with us. Jai Shri Krishna, Jai Hind, Jai Bharat, Vande Mataram.